Alright, this is for ASGNQ305. Simplifying rational expressions. This was Monday's assignment. Okay, I'm doing number 2 as a sample problem. Alright, so I'm going to factor out the x cubed plus 8. That will be x plus 2 times x squared minus 2x plus 4. This was a recent quiz. You were supposed to know the pattern. This is a sum of two cubes. X to the third is a perfect cube. 8 is a perfect cube. 8 is 2 to the third power. That's what a perfect cube is. Right? So 8 is 2 to the third. Remember, exponent of 3 is cube. Alright, so here, what's being cubed here? Well, obviously x, if it's being raised to the third power, so that's x. And what's being cubed here is a 2. So that's the sum of two cubes. And this is the way you factor it. The x cubed becomes x, the 8 becomes 2. Now, so you ignore that, and then you follow with the rest of the formula. Right? The rest of the formula says take this first term and square it. So that's where the x squared comes from. And then change the sign from plus to minus. By the way, this plus and this plus, they have the same sign. And you're going to just ignore, now just multiply the 2 and the x. That's where the 2x comes from. And then the last term is always positive, and you square the second term. So that's plus 4. Alright. And this term here, this trinomial, can rarely be factored. It's rare that can be factored. Alright. I want to factor the denominator. This is a difference of two squares. X minus 2, x plus 2. That's how that works out. Okay? When you have, this is a perfect square. X squared is a perfect square. 4 is a perfect square. 4 is 2 squared. So it's x2, x2. And you need two different signs. What happens when you have different signs? The inside is negative 2x. The outside is positive 2x. Negative 2x, positive 2x cancel each other out. So this one has no middle term like this one does. Right? Alright. Now let's look at this one. This one I'm going to factor similarly. Right? X squared is x and x. So there's no choice for x squared. That's the only way x squared can be broken down in terms of multiplication. Now, 4 has several choices. Right? You might think there's only 1, 2 times 2. But there's also 1 times 4. Okay? But here's the way I look at it. What combination of the factors of 4 combine to make negative 4? Well, negative 2 times negative 2 gives me positive 4. Negative 2 plus negative 2 gives me negative 4. So that's how you got to choose this, right? Choose the factors that are going to go here. So it's minus 2, minus 2. Now let's double check, right? I chose the x and x because x times x is the only combination to get x squared, right? And I chose negative 2 times negative 2. That gives me a positive 4. But I still have to check to make sure I get the middle term. To do that, you do the inside, which is negative 2x, and the outside is negative 2x. Negative 2x with negative 2x makes negative 4x. So that was correct. And then you might think, well, how am I going to factor that one? Well, look here. Don't factor it. If you already see something exactly like that, don't factor it. Actually, in fact, you can't factor that. Right? I just told you this can't be factored. Well, that's the same thing. It can't be factored. Alright. Okay, so now what we're going to do is do some reducing. So here, these can reduce. And the x plus 2, x plus 2. What's the rules for reducing? The factor you have, and it has to be a factor. It can't be something, like if I have a plus sign between these two parentheses, that's not a factor then. Right? So it has to be something times something, right? This big thing. I know it's got plus signs in there, but that itself is being multiplied with this thing over here. So it has to be a factor, and they have to be on opposite sides of the fraction line. So here, this is above the fraction line, this is below the fraction line, so that can cancel or reduce, right? So here, x minus 2 can reduce with this x minus 2. This x plus 2 can reduce with this x plus 2. Alright, so the only thing left is this x minus 2. And in fact, that's the final answer. This is the answer, x minus 2. Just everything else reduced. Okay. Alright, let's do another one. Let's try number 4. Number 4 is big at the moment. Alright, number 4. Oh, there's a typo on this one. Okay. Depends on when you got your worksheet. This on the original worksheet, there was a typo here where there was no exponent, but the exponent should be 2. All right. Oops, you can't see it. Oh, okay. On some of the, depending on when you got this, there was an exponent missing from this problem. That has an exponent of 2, right? In the original printout, it was x to the 4 minus 6x with no 2 plus 9. But it needs a 2 there. Alright, so let's factor this out. This is a quadratic form. What's a quadratic form? A quadratic form is a trinomial, like this. This is a quadratic. This is a regular quadratic. This is not just quadratic form. This is a regular quadratic. Quadratic has an exponent of 2, and then x with 1, right? That's an exponent of 1, and then no x, right? This doesn't have that exact form. However, the quadratic form goes like this. You have an even leading exponent, and then the middle term has half that. Okay, so if this were x to the 6th, for the quadratic form, this had to be x to the 3rd. If this were x to the 10th, then to be a quadratic form, it has to be x to the 5th. Okay, but this is the quadratic form. And this factors just the same way this one does. Okay, the difference is x to the 4th, we're going to break it up into x squared. If it were not quadratic form, like some other power of x, I'm sorry, if it were x to the 4th without the quadratic form, it might be like x cubed times x. But when it's quadratic form, you're going to do just split it in half, x squared times x squared. Now, what are the factors of 9 that combine to make 6? Well, -3. Let's double check, right? So the inside is -3x squared. The outside is -3x squared. -3 and -3x squared and -3x squared gives me -6x squared. So that works. All right. Factor the denominator. Well, this one is not as easy. And in fact, I'm going to do some side scratch work. Right? I'm going to do some side scratch work for that. So let me copy the denominator. All right. What we're going to do is factor by grouping. So those two group together, those two group together. Whenever you see a 4-term polynomial, this is 4 terms, right? X cubed is 1, x squared, -3x, -3. That's 4 terms. Whenever you see a 4-term polynomial or a 6-term, whatever it is, even number of terms, try factoring by grouping. All right. So here, I'm going to take out an x squared of the first 2, just the first 2. I'm grouping those 2 together, right? Remember, when you're factoring out something like this, you subtract the exponents. 3 minus 2 is 1, so that's 1. And x squared divided by x squared is 1. This is division when you're factoring out. It's not subtraction. It doesn't become 0, right? It's x squared divided by x squared is 1. Now, I'm going to take out a -3 out of this, okay? Whenever you're factoring by grouping and this term is negative, you're going to take a negative out. It doesn't matter if this one's negative or not. If this term is negative, you're going to take a negative out. All right, and then take it out. That becomes x plus 1. All right, so take -3 out of -3x, that leaves the x. -3 divided by -3 is +1. And look, these two are the same. If those were not the same, then either you did something wrong, or 2, factoring by grouping doesn't work. Okay, for the problems we get, it's going to work for 90% of the problems. Okay, all right. And on the test, I'll even give you a hint, and I'll let you know if that's going to work or not. Anyway, maybe, if you're real nice. Anyway, so I'm going to take out an x plus 1. Right? That's the common factor between these two groups. Right? X plus 1 is a common factor. That's going to leave me x squared minus 3. All right, so what I've done is factor the denominator. Factor the denominator. I factored that. And this is the work. So it's x plus 1, x squared minus 3. Okay. Sorry for yelling. All right. Here, x squared plus 3x plus 2. That's going to factor like normal. X squared is x times x. 2. There's no choices for 2. It's 1 times 2. All right. And let's double check though. 1x is inside. 2x is outside. 1x plus 2x makes 3x. So that worked. Okay. By the way, most of these are going to work. Okay. What do I mean by that? Like, there was no other choice for this, right? If it didn't work, that means it can't be factored. All right. Oh, another factor in my grouping. More work on the side. All right, let's do that one. Okay, oops, my computer just went down. All right. So x cubed plus 2x squared minus 3x minus 6. All right, let's take out x squared out of that. So that gives me x plus 2. Let's take out a negative 3 out of that. That gives me x plus 2 again. Okay, so you have a common factor of x plus 2. So that's x squared minus 3. Okay, did I go too fast? Well, I explained the other one. Alright, so, oh yeah, parents are watching this too. Well, you can always request me to do it again. Anyway, alright, here we go. Now let's do some canceling, right? So x squared minus 3 reduces. And I have an x squared minus 3 over here with an x squared minus 3 over there. So that reduces. Oh goodness. X plus 2, x plus 2, x plus 1, x plus 1. Everything goes away. Now, remember this is fractions. When you can reduce a fraction, when a fraction complete reduces, it doesn't turn to 0. It turns into 1. So final answer is 1 for number 4. Okay, continuing with ASGNQ305. Yeah, I had a coughing fit. I had to stop the video. Anyway, alright, this is number 12. This is an addition problem. And what we're going to do is break up the denominator, or factor the denominator rather. In the other problems, we didn't have to factor because they were so simple. Here, we have to... Okay. Oh, I didn't explain how I got any of that, did I? Well, this is a difference of two squares. When it's a difference of two squares, it always works out like this, right? X squared breaks into x and x. 4 is a perfect square. What's a square root of 4? 2 and 2. And you're going to get a negative version and a positive version. Okay? Here, x squared is x and x, and 4 is 2 and 2. In order to get a negative 4 using positive number here, right? To get a positive number here, they have to be the same sign. And since I need a negative, I need them both negative. Okay, so I think this is a good example of seeing how this sign changes the quadratic that's formed, right? If they're opposite signs, it becomes x squared minus 4. If they're the same sign, it's just trinomial. Okay, all right. Now, so what's the common denominator? Well, I'm sorry, let me just copy the numerators here. So I haven't done nothing except factor the denominator. I am not even ready to add yet. I have to find the common denominator first. The way you find the common denominators is you list all the factors. So we got x minus 2 and x plus 2. But the problem is this x minus 2 over here is listed twice. So that means x minus 2 has to be part of the denominator twice. So if it's x minus 2 twice over here, it has to be twice over here. Okay? Now, so this denominator is missing the x plus 2, so we put the x plus 2 over here. Okay, so what I've done is change the denominators to the common denominator. So going from here, x minus 2, x plus 2, to here, I've got a new factor of x minus 2. So I'm going to put that to the numerator. Okay? All right. Now, coming over here, what's the new here? Is the x plus 2. So I need to multiply the numerator by x plus 2. I realize many students have a difficulty understanding this concept. If you didn't get it from this video, please feel free to ask me again in class. Alright? Alright, so here, let's go ahead and multiply that out. 4x minus 8 plus x squared plus 2x over that denominator. Alright, combine some like terms. Oops. And by the way, if you want to write x minus 2 to the second power, that is perfectly fine. Okay. Alright. Now you might think you should factor the numerator. Well, you could try. I don't think it does. Right? To get a 6 out of negative 8, that doesn't work. Negative 8 has to be like different signs, so it's negative 4 and positive 2. Or 8, negative 8, and 1. There's no way to make that the 6. Okay? Since this is factoring and not solving, you're not going to use the quadratic form. Alright, so that's number 12. And there's another one I want to do for you. Let's do number 22. 22. Yeah, this is a funky looking problem. This is 22. This is actually a combination of everything you know so far. Alright, so what you have here is division, and here's the division. It's x minus 3 divided by this mess. And this has adding or subtracting fractions. So that's what this is, subtracting fractions. Okay, so what I'm going to do first is not mess with the numerator. I'm only going to mess with the denominator. So here, you have to find a common denominator. Well, it's easy. There's only one denominator. So the common denominator is x plus 4. And you might think, well, that doesn't even have a denominator. Well, they all have a denominator. So the common denominator between x plus 4 and 1 is x plus 4. So the first fraction doesn't change at all. Okay. But the second fraction, that 1 changes to x plus 4. Right? I multiply the denominator by x plus 4, so I got to multiply the numerator by x plus 4. Okay. All right. Now, I'm just copying the original numerator. Now, here, combine. So it's 2x minus x is x. 1 minus 4 is negative 3 over x plus 4. Now remember, this line here is a division line. Okay, so that's going to be, and do you remember what happens when you divide fractions? You multiply by the reciprocal. So I'm going to flip this. So it's going to be x plus 4 over x minus 3. And wow, look, x minus 3 reduces. Right? This is like over 1, so x minus 3 reduces. So final answer is x plus 4. And that's the weird problem. Right? I know it looks weird, but it is a combination of all the things, all the skills you've developed so far. All right, that's it. I hope that's helpful. Bye-bye.